Hello everyone, good morning. Welcome back to my channel Learn Tech with Kiran. In today's session, we will discuss about context-free grammar. Before this, we understand about why do we need context-free grammar. In some of previous lecture, we learn about finite automata like DFA and NFA. These machines are very powerful when it comes to recognizing a regular language such as string with a fixed pattern, repetitive symbols, basic tokens, structure like a identifier, number, keywords, etc. But finite automata have a limitations. They don't have a memory, and that's why they don't able to keep a track of long range in a string. They do not able to count, and that's why they don't able to compare even. We can able to solve problem like ends with, start with, substring, existence of a language by using DFA and NFA. But problems like a raised to the power n, b raised to the power n, and similar like that, like parenthesis count and any count of symbol appearance or a tracking, maybe not possible, and that's where your context-free grammar help us. Okay, let's consider one example where a raised to the power n and b raised to the power n, where n is a greater than or equals to 1. Okay, so you consider a 3 times and b 3 times. You can solve this by using DFA and NFA, but if we need to check whether number of a equal number of b, here we need memory for a counting, and here your CFG comes in a role. Now, what is mean by context-free grammar? Context-free grammar is a set of rules that describe how string in a language can be generated. Okay, CFG generates strings repeatedly by replacing a variable with terminals. Okay, based on the production rules. Okay, your CFG or context-free grammar generate a context-free language. Okay, they can represent nested hierarchical structure like parenthesis or a block in your program. Then where you can use this? So it is widely used in a compiler design, in especially parsing and syntax analysis phase. Okay, so this is all about what CFG and where it is used. Okay, now let's discuss how it can be defined. Now, you can define a context-free grammar by using 4 tuples, which is nothing but a V, T, P, and S. Now, what is V, what is T, what is P, and what is S stands for? Okay. So, when you are writing a V, it means that it is a set of variable and non-terminal that will help you to represent a language. Okay. And describe recursively in terms of each other. V is mentioned in a capital letters in context-free grammar. Okay. Now, what is mean by T or why we using a T? T is a set of terminals, or you can say actual symbols in your language like A, B, 0 or 1, etc. Similarly, those symbols you wanted in your language, these are mentioned in T. Okay. Now, next one is a P. What is mean by P? P is a set of rules or a production rules, you can say, which describe how non-terminals can be replaced terminals or combination of terminals and non-terminals. Okay. So these are some rules which is used in a language generation. Okay. Then what is mean by S stand for? So basically S stands for a starting symbol in your context-free grammar. Your string is initiated with the help of S or any starting symbol you are mentioned in your context-free grammar. Now before discussing example and understand it more, first we discuss about a form of your CFG or form of your production rules in CFG. Okay. In CFG, each production rule look like this. Here you can see capital A instead A, small a. Okay. So what is capital A and what is small a here mean that? You can see over here in a left hand side we have used a single non-terminal in a capital letter, which is nothing but your variable or a non-terminal. Okay, so it's supposed to be always a single one. Okay, you can't mention over two symbol in a left side. Then you can see A, which is can be terminal or non-terminal or a combination of both terminal and non-terminal. Okay, so basically this A is replaced by this one. Okay, so wherever your A is standing, you can replace this with this small a, which may contain a terminal or a non-terminal or combination of terminal and non-terminal. Okay, I hope you understand this. Let's see a natural language grammar example before the grammar. So here you can see sentence, nouns, adjective, noun phrase, then verb phrase. Okay, so these are some non-terminals which is used in your natural language. Then little and boy, these are terminals. Okay, so by using this natural language rule, you can able to build a valid string or a valid sentence. Okay, similarly we have to design a context free grammar for your context free language. So you can generate context free language by using this context free grammar. Okay, I hope you understand this. Let's discuss one example how context free grammar can design for a context free. So this is one example of a context free grammar. Problem statement seems like write to CFG for the following language, where language is equals to a raised to the power n, b raised to the power n, where your n is a greater than or equals to 1. It means your appearance of a and b is always greater than equals to 1. Okay. Now, for a getting language from this problem statement, we have to replace n with a 1, then 2, then 3. So, you can get your language. Okay. So, basically your language may be defined as something like this. Here n appearance is a 1, here your n is a 2 and here n is a 3. So similarly you can mention another language over here. Okay. So by seeing this you can understand we have to generate a equal number of A's followed by equal number of B's. Okay. So basically this problem solving statement is not able to solve by your DFA or a NFA. Okay. So that's why your context free grammar comes into the role. Okay. So how can you solve this problem statement by using your context free grammar? So you can define your context free grammar something like this. Now in this grammar your important part is production rule. The way you design this production rule define your generated language. Okay, as per language your n supposed to be greater than 1. Okay, by using this grammar you can generate a string or you can generate a language which is fulfill the condition given in your problem statement. So for this you define your variable or a v as a s, then your terminals are a and b, then these are the production rule which is designed for this problem statement. Okay, and this is your starting point s. Now how can we design this? So basically understand one string. So you can see at least one appearance of A and B supposed to be there. So that's why language is AB. For this you have to generate directly at a starting point. You can substitute your S to the AB. Okay. So your first string is design. Now for a second string you have to understand. Now your first production rule is S tends to A, S, B. So I consider this as a starting string. Now I replace this S by again this production rule which is nothing but S tends to A, S, B. That's why this string is over here. Okay, and then third time I need this. So again I replace this S to A and B. So here you can see this substring. So that's why your AAABBB substring is generated. If you want to generate your second string, then what you supposed to do? Firstly, you initiate with your starting string, then you replace this S directly with this AB. So it become a AA and BB. Okay, I hope you understand this, and this is the way you have to generate your context-free grammar for given languages. Okay, I hope you understand the concept and example. That's it for video. In next video, we will discuss one more important point in theory of computation. If you found this video helpful, don't forget to like this video, share with your friends and subscribe my channel. Thank you.